everybody for joining us. My name is Lynn. I am a sales rep here at WarmlyYours, and today I am joined by our wonderful tech expert, Scott.
Hello, everybody. Thanks for joining us today.
Yes, thank you so much. So today we are going to be talking about heating underneath laminate, engineered, and hardwood floors. So if you have any questions, please don't hesitate to ask. We are also going to be sending over a 10% coupon for you for attending today's webinar. So that should be in your inbox not long after we finish up today. So be sure to check that
Okay, let me
out.
let me hit the right button here. That always helps.
Awesome. All right. So thank you again for joining us. If you have never been to one of our webinars, we are Warmly Yours, and we have 26 years as the radiant heating experts in the industry. We do really pride ourselves on 96.8% customer satisfaction. We really love our customer service, and that's what we are here for. And on top of that, not only do we offer our industry leading warranties on all of our products, we also offer 24/7 technical support. So at any point, if you need any assistance or have questions, we are always happy to help out. And Scott is one of the people who often takes those 24/7 tech calls. So you might even be lucky enough to chat with him.
Lucky or unfortunate, that'll be determined later. But I did want to let everybody know that we do have a 10% coupon for everyone who is attending today. So how's that? How are they going to get that, Lynn?
Yes, so we should be emailing that over. I believe once the webinar is over, you should be getting an email with that coupon shortly. So like I said, today's webinar is all about wood floors. So we're going to talk about the different types of wood floors. We're also going to talk about the different installation methods by the system that you'll be installing. We'll go over the installation steps, and then at the end, we'll also talk about our different controller and sensor options. So adding electric heating to a wood floor is a really, really great option for your home because radiant floor heating actually works by distributing heat throughout the space evenly. It doesn't have any cold spots or blowing air like you get with forced air systems, and it actually works by warming up you and the objects in the room. So it actually is a very efficient way to heat a space. And because you're not going to be using any forced air, you're not getting, again, those hot and cold spots where air can kind of tend to get stuck or tend to blow directly. And you're also getting a lot less dust and allergens and pollutants kind of blowing around in your home. So it is a consistent, comfortable, and safe way to heat your space. And Scott, I know you are a big part of this with our industry standards. We have some compliance partners that we work with to make sure that all of our products really meet the highest standards. Can you kind of tell us about some of those organizations?
Yeah, the NWFA is the National Wood Flooring Association, which we've done a lot of work with over the years. Hard to imagine, but only just a few years ago, uh, the National Wood Flooring Association really wasn't too hip on electric heat until we described how it's actually better for wood floorings to have electric heat as opposed to hot water. So we've been working with them quite a bit. The North American Laminate Flooring Association, RPA, Lowenstein Hardwood Floors have actually been to their factory in Michigan to visit them and go over their testing with them. So these are all great partners that we have worked with in the past, we continue to work with, and also people or associations that set up guidelines. You know, like what is the highest temperature as a general rule? What's the highest temperature for a wood flooring? That's always up to the manufacturer. The manufacturer is always the answer, but you will see the National Wood Flooring Association recommendations mentioned, and those are just a general guideline. If you can't find any information about your particular floor, they would be a good thing to reference. But once of all, they're just a general guideline. Most of our recommendations today are going to be contact the manufacturer because they will have their specific rules. So
Yeah.
that's who we've worked with, who we continue to work with.
Absolutely. And we really stand by these strict standards because they result in really great product reliability. And we have a lot of trust with our customers. People know that our products are safe and guaranteed to work the way that we promise them to.
Right. And a lot of people will ask, well, how about if I try this? How about if I try that? And all we can say is we just need to follow what the flooring manufacturer says to do. It's not really up to us. And if we tell you to try, say, hey, why don't you try this? And it's the wrong information, then no one wins, right? That's the
Yeah,
thing to keep in mind. So we're always going to defer to the manufacturer or these guidelines because they are the ones to follow, not conjecture. Hey, how about if I try this? So it's better to have a proven system than one that is like, hey, what do you think? Or will this work?
sure, absolutely. And I know you had touched on this briefly. Obviously, hydronic systems have been around for a very, very long time. That is actually using a boiler and hot water to heat a space, whereas everything that we offer here at WarmlyYours are all electric radiant heating. And obviously, there had been some concerns and considerations when doing hydronic systems with wood floors, and electric tends to be a much better option. So, can you kind of tell us what the difference is and why electric might be better for wood floors?
Well, if you're doing a remodel of a room, electric is much, much better because you don't have to go out and buy a boiler. You don't have to go out and buy pipes. You don't have to go out and buy valves. You don't have to worry about water leaking. You simply just run an electric line to where that room is that you want to heat, and you now are ready to go. So it's much less labor intensive. The physical plant doesn't need to be changed because you've already got electricity in your house. You may not already have a boiler and water and all that other stuff. It's also applied in a thinner manner. We're going to heat the top section of the floor right below your feet. We're not going to heat the whole slab in most cases. So we're going to be minimizing on hot and cold spots. One thing about when you have a boiler, the water temperature is the hottest it'll get right when it comes out of the boiler. The further it gets away from the boiler, the more the temperature drops. So you'll see these designs for hot water systems where they quite intricate. They run the hot water in through this room. All the water ending the room at this spot's really hot. By the time it exits the other side of the room, it's all cooler. So you have a hot spot right when it enters the door, and then it's a cooler spot down at the end when it leaves that particular space. Well, with electric, it's the same temperature at the beginning as it is at the end. And what's always surprised me, we don't have to worry about that thickness, that height thickness. So if you're going to come in and say, I'm going to retrofit a boiler and I'm going to put hot water pipes in here, well, you're raising the floor, an inch, 2 inch, 3 inch, however you have to do it to do their work. Ours is just going to be an eighth of an inch. So you're not going to be, cutting all your doors. You're not going to be changing all your trim, that much of a deal. So one thing that's always surprised me too is hydronic has been okayed for these systems for years. And the funny thing is, the older hydronic controls didn't even have a floor sensor. It was just simply based on calculations. If I get the water this hot and I do so many gallons per minute, the room in the temperature in that room is going to get to this. I calculated it. Well, with electricity, you just turn on the power until it gets to that temperature, then it turns the power off. And then it regulates the temperature right there. There's no calculations or anything going on. It's actually what is the temperature in the floor. And our controls can keep that within 1 degree. There's no overshooting, which is what hot water systems do. The boiler comes on and it pumps the hot water, your temperatures go up. Then it pumps cooler water, the temperatures go down, and you're just on a ride up and down, called overshooting and undershooting. And that's what you get with hydronic systems. With electric, you don't. The same temperature all the time, the same temperature at the beginning of the room as it is at the end of the room. So there are no boilers to work on. There are no pumps to work on. There's no maintenance to do. There's no water leakage that you have to worry about. So the main takeaway is electricity is going to be much faster and easier to install, no maintenance, and we're going to be able to regulate that temperature, which is very, very important to wood floors. We're going to be able to regulate that temperature much, much better than you can with hot water.
Yes, absolutely. So there are lots of different wood species out there, and certain types are better for heating than others. And I know you have worked a lot with, as you said, Loungstein. That's how it's
Hmm.
pronounced.
Yep.
Just I know that you've worked with them quite a bit. So can you kind of tell us what have these tests shown? What are the best species of wood for radiant heating?
Well, it's not only the wood species, but it's how it's cut. And the biggest thing that we're going to be talking about later is relative humidity. When you're installing a wood product in your floor, you need to worry about relative humidity because people will say, well, you know what? My floor buckled this year because of the electric radiant heat. Well, it didn't buckle because of the electric radiant heat. You put the product in the wintertime when the wood shrunk, and then in the summertime, it expanded and buckled because you didn't look for your relative humidity. So there's more than just a couple things that go in on this. And what you want to do is you want to look for the wood species that's the most dimensionally stable. Does it expand and contract this way? Does it expand and contract lengthwise? How do different cuts make it bend or buckle or deform? So what we want to do is we want to recommend the most durable species. Oh, you know what? I really love Brazilian cherry. I love it. I love it. Well, okay, you can love it, but we want you to have a nice floor that you don't ever have any troubles with. And Brazilian cherry is not the one you want to put in. It may look great, but it's going to do this and that, or it may expand. It has extreme hardness. It has significant movement issues. You want a piece of wood that stays as close to its original size as possible. It doesn't shrink a lot and it doesn't expand a lot. And that's because of the water in the air. So you are going to look for white oak, American cherry, walnut, mesquite, black cherry. Those are the ones you want to look for. If you say, you know what, I've got some radiant heat and I think I'm going to get hickory floors, please don't do that because you're picking one of the worst ones to use with a product that is not really designed to be used with. So always look for white oak, American cherry, walnut, mesquite, or black cherry. Those are the ones that you want to go towards. Stay away from hickory, stay away from maple, stay away from beech, and stay away from Brazilian cherry.
Good information to have. Thank you, Scott. And then, as you had kind of mentioned earlier, it also is very affected by the types of cuts and the width of the cuts. So, can you kind of tell us? I know you're not especially a lumberjack, but can you tell us a little bit about some of the wood cuts and how they play a role?
Well, yeah, the thing is, you don't really need to be a lumberjack and to know or to work in a mill to just remember that quarter sawn is usually going to be the most stable. So if someone comes up and goes, I've got quarter sawn for this much and I've plain sawn for this much, don't choose plain sawn because the more stable the wood is, the wider you can have the boards be. The less stable it is, the narrower they have to be. So if you look at their quarter sawn, it's the most stable. You can allow wider boards up to 7 inches. Then compare that with plain sawn, and you need to limit that to narrow widths, only 3 inches wide. It's a very common cut, but it's the least stable. So what we're trying to get across here is use the most stable wood you can find and use a quarter sawn version of that if you can, because now you're going to have the most stable system that you can, because you have a very stable way of the wood because of the way it's cut, and you have a very stable wood to begin with the way it is in nature. So that's what you're going to be looking for, are quarter sawn in the approved or recommended types of wood. So if you get the choice, quarter sawn, plain sawn, always take quarter sawn. That's all you need to take away from this. You don't need to remember how it's cut or where it's cut or anything like that. Just remember we showed you these just to trigger that memory to use the correct wood cut the correct way.
Quarter sawn, got it. And you had mentioned some of the differences in width. So, can you kind of tell us, what the guidelines are on that?
Well, you've got solid wood, which we do plenty of installations with. Solid wood is usually a nailed down application. You also have engineered wood. Engineered wood has the pretty wood on top and then a couple different grain patterns or plies underneath it, usually going in opposing directions, giving it much more stability so it doesn't just shrink in one direction. It kind of contracts from all directions, so it minimizes the motion. So if you look with solid wood, we suggest 3 inches or less. But if you use engineered wood, you can use up to 5 inch acceptable with a proper installation, proper relative humidity in the room. Quarter sawn up to 7 inches possible due to superior stability. Now, one thing that you want to do is if you're going to be doing this is you want to like a floor looks really great when the pieces of wood are right next to each other and you have perfect humidity. But if it dries out, the pieces of wood can separate. We call gapping, and gapping can be noticeable if those are all flat pieces of wood stacked right next to each other for a very smooth effect. The way you can minimize the vision or seeing that gapping is actually to use beveled edges. So there's always a bevel there. There's always a little slight depression in the wood. And if it pulls apart a little bit, it's really not very noticeable at all. So beveled edges are a great thing to use with very stable wood and the quarter sawn wood. And it's going to really, really disguise any of that minor gapping that you may get in extremes of humidity, low humidity and high humidity.
Awesome. And this is a really great diagram showing what you had mentioned earlier regarding solid versus engineered wood. And obviously, you can see in the drawing the different layers with the different, cuts and way that it's run for the engineered wood. So, can you kind of tell us, what is the best option? What are some requirements, guidelines, things to keep in mind when picking?
Well, solid hardwood is beautiful wood, and it's 9 times out of 10 it's going to be nailed down, and we do lots of those installations. We've got an application we're going to talk about a little bit later. It very important to get the correct species and to get the correct cut. Also, make sure that you follow the temperature limits. Also, you are going to follow the acclimation required by the manufacturer. It may be 7 days, it may be 21 days, or whatever that number is, you're going to want to find that. And you have a chance at greater expansion and contraction as opposed to engineered wood. Where engineered wood we talked about here on the right side, you can see there's multiple layers, just the pretty wood on top, and then the other wood going different directions to keep it more stable. So it is a very good wood is engineered wood. You'd want to check and see if the manufacturer allows that to be used below grade. They may want you to use something else below grade or above grade. Those are the kind of questions they're going to say, where are you going to put this? Is it going to be above grade or below grade? And you're going to want to answer those questions. Um, Engineered wood is usually a thinner application, so it's going to translate more heat into the space. It usually can handle slightly higher temperatures. Always check with the manufacturer. And what you want to do is the thicker the product is, usually the higher the R value. What we want is we want something with a low R value to let the heat up into the room, as opposed to putting electric wire here and then putting something above it that's got an R value of 2 or 3, which is going to trap the heat underneath. You want the heat to escape and come through the floor into the room. So that's where you're going to be worried about your thickness considerations. Usually solid wood is 3/4 of an inch. Engineered is thinner, um, means more heat's probably going to get into the room, probably a lower R value. Laminate is a very good product to use because it's a little bit thinner. And just the main thing is to keep in mind is that the lower the R value, the more heat you're going to get in the space. Engineered wood is dimensionally more stable than hardwood because it keeps it from moving around like so much. One thing you have to do with solid hardwood is you want to ask the manufacturer, what is the nail rate? Because usually those are nailed down applications, and a nail rate they'll tell you, well, it needs to be nailed every 3 inches or every 8 inches or every 12 inches or every 15 inches, whatever that is. That's very important to know. And we're going to talk about that in a little bit.
Absolutely. So we offer a few different heating products for different types of flooring and different applications. Our TempZone cable is really great for custom layouts or for more odd-sized or shaped rooms, and it's also really great for sleeper installation. So if you're going to be doing that nailed hardwood, as we had spoken about, cable is going to be usually the best option. Now, our TempZone mats are very similar. However, they're really designed for super simple, standard sized rooms. They're cut and turn mats that can be fit into a space very easily and quickly. Now, both TempZone and or TempZone cable and TempZone mats do need to be fully embedded in either thin set or self-leveling concrete, and we'll get to that in just a moment here. And of course, our Environ mats are great for floating floors, really great for going underneath engineered wood and other applications like that. So keep in mind, all of these systems do include a free backup sensor for your flooring, as well as our professional tech support and our professional installation planning assistance.
Remember, the two on the left are the ones that need to be embedded. The one on
Yes.
the right does not need to be embedded. It goes in a purely, the environment mats are never attached to anything, and nothing is ever attached to them. So we had a question from Jim. Jim is asking, where does mahogany fall in the compatibility category? The perfect place to go for that is the National Wood Flooring Association. They have a list of each type of wood and what is better, what is worse. So they are the wood flooring experts. That's where you're going to want to go, the NWFA, as we spoke about earlier. So Jim, I hope that helps. They are the experts on that, and they will be they have tons. You can get lost on that website really, really quickly. They have tons and tons of information. So hopefully that will help you.
Awesome. So, as we had mentioned, there are different types of installation methods for each of those different types of floor heating systems. So, starting with our TempZone cable, as we had mentioned, that's going to be best when you're doing nailed down solid hardwood. Can you kind of tell us, Scott, what that looks like in terms of installation?
Yeah, we've got a showcase coming up about that. So we'll give everybody a really good look at that. But what it is you're installing sleepers. The you've asked the manufacturer of the nailed down hardwood what the nail rate is, and they're going to say every 8 inches or 10 inches or whatever that is. You're going to then install sleepers that are 3/8 to a half inch high, every on center 8 inches apart or 10 inches apart or 12 or whatever that number is. And then in that space, you're going to run the cable back and forth in that space at the correct spacing from wire to wire. And then you are going to cover that with self-leveling so it's the same height as the sleepers and then nail down into that. So the system gets installed, the wood actually sits on the sleepers and also right on the self-leveling. So it's a traditional way to install wood by nailing it down. We're just doing it into sleepers instead. Any nailable hardwood is a good match as long as the nail rate isn't 1 inch, because you can't get cable by then you can't put enough cables in the floor to get it warm. If you've got a bunch of sleeper, the more sleepers you have, the closer together they are, the less room there is for that wire to go. So you want to watch out for that. Um,
Yes, absolutely.
Temp zone mats are great for glued down applications, because what you do is you put those temp zone mats down on the floor, you hot glue them to the floor, and then pour self-leveling over them, a half inch of self-leveling. That's going to give you a very flat surface that you can glue the product down onto. So that's going to be your flat subfloor is going to actually be a heated subfloor. So you want to watch out, make sure you get adhesive that's radiant compatible. Make sure that you let the SLC, self-leveling cement, make sure that you give it time to cure and to dry. And it is faster than cable systems. You just lay it out, hot glue it down. Now, both of these systems have been with self-leveling cement. Self-leveling cement's very, very dense. So you want to make sure that you attach the cables or you attach the mats very well to the subfloor, because if you don't, they're going to go up to the top of the pour, and then you're going to have to pour another layer over the top of that because you can't have the cable at the top. So those products have to be attached very well to the subfloor. And then Environ mats, that's the fastest installation that you can do. You run your non-heating lead from the thermostat down the wall over to where your heating is going to start. You roll it out on the floor and you install the flooring on top of that. It's very, very fast install. There's no cement, there's no thin set, there's no self-leveling. It's the fastest installation you can do, and that is going to be a system that you're using with laminate. So a lot of times the surface temperature can get up to 85. You do have a 48-hour acclimation period. Sometimes it's longer, maybe less. And you are always going to want to put thermal sheet, which is 6 millimeters or a quarter of an inch thick. You're going to put that down as the pad because you can't put a hard surface like laminate on top of Environ and then have the Environ sit on another hard surface. You can't do that. So you put on your subfloor, you put the thermal sheet down, you put the heating product Environ, and then you lay the laminate on top of it as a floating installation. And that is going to be a perfect install, very, very quick for you. Now, one thing, LVT, LVP, whatever you want to call it, luxury vinyl tile, it may look like wood, but it's very durable and it's versatile, but you have to install it correctly. And you are going to make sure that you are going to be using LVT is always going to be done with an embedded type of installation. Even though it says floating, you can't do that because of drapage, because of drape. Vinyl drapes over whatever it sits on. It tends to conform to whatever is under it. So if you ever go to someone's house and you see they have a vinyl floor and it's about 5 or 6 years old, you'll start to see where if they installed it over another vinyl floor that was going the different direction, you'll start to see that coming through the top of the LVT. So that's the big difference between LVT and laminate.
Awesome. That's great information. Thank you. So when you're looking at actually beginning your installation, one of the first things is to keep in mind is that you want to make sure that you are preparing properly. So obviously we have said a few times now, talking with your flooring manufacturer, following acclimation requirements, things like that. However, we always recommend as well making sure that the subfloor is very prepared, making sure it's clean, degreased, and that it is level. And then once you lay out your cables and mats, we always recommend following our smart plans. So our smart plans are something that we provide to you. They're complimentary, and it's going to actually show you exactly which products we'd recommend for the space and how they'll be laid out so that you go into it with a really good game plan. So make sure that you're following those smart plans as well as all of the installation requirements. Scott, can you kind of tell us a little bit about the actual placement of the sensor and where it should be going in the floor?
Yes. The installation that we're discussing here, Asher had a question about LVT. And I think I didn't see his question, but I think I answered it, or he or she's question. Sorry about that. I think we answered the question by saying that LVT can be installed over self-leveling that embeds our TempZone system. That's the type of install you want, not the Environ. So hopefully that answers your question, Asher. Thank you very much for asking that. The floor sensor, you want to make sure the floor sensor, people go, well, how the floor sensor is only so long. How do I get it out of the middle of the floor? Well, you don't want it to go into the middle of the floor. You only need it to go in about 6 inches from the edge into an area between two of the heating loops. So if your heating loops are 2 inches apart, or if they're 3 inches apart, the sensor would go right in the middle of them. Never install the sensor right up against the heating wire because your system won't work correctly. Also, you're going to get 2 sensors at least. You're going to get one in the thermostat box, and you're going to get one attached to the cable or to your heating product, whichever one it is. You install both of them within 6 to 8 inches of the edge into an open spot between two of the cables. And then you are going to run them both up to the thermostat. You're only going to attach one. You're going to leave the other one dangling there unattached. and that is where you're going to put it. Also, you want to see on your floor where sun is going to hit it, because you do not want the sunshine to hit that sensor, because when it warms the sensor up, the sensor goes, oh, it's nice and warm in here. I can turn the heat off. Well, it's warm right where the sun hits, but we're in the other part of the room where the sun isn't hitting, then it's going to be cold. So watch out for that 6 to 8 inches into the edge between two of the heating wires, not where the sun's going to hit. So that's very, very important.
Absolutely. And when you're working with self-leveling cement going over the heating product, you do want to make sure that you're priming that subfloor when you're doing the initial cleaning and leveling, making sure that you're following all the manufacturer specs for your specific self-leveling cement. And then you'll also follow those specs for mixing it and pouring it out. Just make sure that any of those standard cement tools that could cause damage to the heating cables aren't used. You want to be a little bit careful during that actual cement pour.
Yeah, make sure that if you have heating vents in your floor, you're going to want to make sure that you put a little dam around them so the
Yeah,
self-leveling doesn't run down into the air vents. Also, make sure if you're on the second floor that there's no holes drilled into the floor, because the self-leveling will run into that and run into the room below it. Also, make sure that you put a dam around the edges of the wall, because if there's a spot for that self-leveling to escape and run down your walls, I don't know how your construction is, but always look out for where do I need to keep, it's just treat it like water. If I pour 20 buckets of water in here, where do I want it to stay? I want it to stay in the room. I don't want it to go down the walls. I don't want it go into the room below me. So simply putting a piece of tape over a hole in the subfloor, I've done that dozens of times. One of the jobs that we have, one of our videos actually shows where we just put a piece of tape over the hole to keep it from flowing into the room downstairs. So with that self-leveling, always assume you're going to need to use a primer. Always assume that unless the bag tells you otherwise. And very, very important to remember those things about self-leveling because you can find out the hard way.
oh, absolutely. And you also want to make sure that that self-leveling fully cures as well. And then after that, you'll install your flooring using the manufacturer guidelines. If you're going to be doing glue down flooring, again, making sure that the adhesive used is radiant compatible, and that if you're going to be doing nails or nailed hardwood rather, that you are installing it perpendicular to the sleepers. So just make sure again that you're talking to your manufacturer and following all the guidelines from them and from us as well.
Yeah, and
And then
we're going to want a plan of that space, you telling us which direction you want the wood to run. Because the job I just went and did, the kitchen already had hardwood and it was running this direction. They wanted to put it in the living room, so it's very important to mark the direction you want the wood to continue going so they can install the sleepers perpendicular to that. So you can get the direction of the wood going from the kitchen all the way through the living room. So that's a good point.
absolutely. And we did get a question. We got a couple questions. Pam wanted to know a little bit more about the 1/4 inch subfloor for underneath the Environ mats. So that's the thermal sheet. That's what it's actually called. And that is a synthetic cork that we recommend, especially I know Pam mentioned putting it down on concrete floors or concrete slab. So you definitely want to make sure that you are putting down that thermal sheet first directly on that slab so that it can not just help to cushion the Environ mat, but it will also help to create kind of a barrier between the slabs so the heat rises properly.
Yes, we want people to, as soon as they go, I've got a concrete subfloor, to know that they are going to need a thermal sheet layer to keep the wire from the heat getting sucked down into the slab as opposed to going up to the flooring where it's supposed to go. So very, very important. Never put an electric heating wire directly on top of a concrete slab because you will not be happy with the results.
Absolutely. And then Jim also wanted to just clarify that the second backup sensor is not connected as a safety precaution, just, to have it there if the first fails. And yeah, that's exactly correct. It's very rare that the initial sensor fails, but it does happen. So that way it's a little bit like an extra insurance policy on it. So it'll keep working even if that first one gives out for whatever reason.
If I've said it once, I've said it a million times. I hate redundancy and I hate repetition. But the good thing about that is if you have and I just had somebody 2 weeks ago who their primary sensor got nicked when it was being installed. So fortunately, they had the backup sensor in the back of the box. They just wired it up to the thermostat and they were ready to go. So that's
There
what
you
that
go.
is for, is redundancy. Remember that. Always good to have a redundant system. Thank you, Jim. Hopefully that answers your question. And Pam did make a recommendation of a question about cork. Now, if you could find, because people are always looking around, sometimes they can't get thermal sheet, but they can get cork. You know, we sell thermal sheet. That's what we prefer you to use because we know it works well. But if you're in a pinch, you can use natural cork. We used to use natural cork a long time ago. The why we don't use natural cork anymore is you can't pour self-leveling over it. If you do, it's going to delaminate from the floor. You have to attach it to the concrete, and all that water content makes it expand. We had some real horror stories of people that were putting cork down on concrete and then pouring self-leveling over it, and then the floor just went bad. It just went like that because of the water content. So, and another thing cork does is you really shouldn't use it in an area where you're expecting water, like basements or bathrooms, because it can harbor and feed mold. Whereas this temps thermal sheet is synthetic, mold doesn't eat it and it doesn't harbor mold, and it's a much better product. A lot of times what you'll do is you go into Home Depot and you'll see a big roll of cork. Well, that big roll of cork may be cork that people use for bulletin boards. Bulletin board cork that you buy on a spool is not the same as flooring underlayment cork. I've seen that mistake made dozens of times. Well, I couldn't get anything, so I bought a big roll of it. And I said, what does it say on the label? Perfect for bulletin boards. That stuff is not subfloor material. So please, if you're going to get cork, don't use it where it's going to be wet. Don't put it where you're going to be covering it with self-leveling. And also make sure that you get cork that's rated as a subflooring material, not a bulletin board cork.
Absolutely.
Okay. Oh, okay. Olivia's typing. So go ahead, Olivia. That one's being answered. Thank you once again to Olivia, who is working in the background with everybody. So thanks, Olivia, for your
Oh,
help.
yeah. Of course. Thank you, Olivia. All right, so moving on, we have two really great showcases showing our product that was actually done under real nailed hardwood floor or real hardwood floors in general. So Scott, can you kind of take us to that first one so we can see what it looks like with the nailed hardwood?
The nailed hardwood, yes. And there's a question there from Thomas. Could you do that while I open that?
Absolutely. So Thomas asked for the maximum temperature for each hardwood, engineered, laminate, and LVP, LVT with the systems. So again, that will vary depending on the manufacturer. So we definitely recommend talking to the specific manufacturer of your product about their specific maximum temperature. A good rule of thumb tends to be, Scott, correct me if I'm wrong, 82 to 85 degrees, depending on the specific product that you're heating or specific
Right,
flooring.
right. Yeah, the manufacturer is going to tell you that answer more than we are. We're going to tell you how to put the system in, and the wood manufacturer is going to tell you what the temperature is and what their requirements are for that. So this is a job that I did actually, and it's close by. And this is a floor that is a nailed down floor. So what we're going to take a look at is what the floor looks like and how we work through it real quick. Um, Here you can see that we've installed the fixing strips. The fixing strips are what we're going to run the cable back and forth through at a certain spacing. We are going to do that spacing by using this installation plan. And you can see the dotted lines are the lines where the sleepers are. And then the cable runs in between those sleepers, back and forth, back and forth. And this was a large room, so we used 240 volts. You don't need 240 volts unless you're over 120 square feet. So we did that with 240. and it worked out perfectly. So that's what the plan's going to look like. So you're going to start by putting those cable fixing strips in. You're also going to, when you're running these sleepers, you're going to leave a gap between them, because you have to put a border all the way around with that you can nail into. So inside that border, you can see that here's tile and here's the border that they can nail into. And that goes all the way around the outside of the space. Then you're going to have a space between the sleepers and that border to allow you to get the cable through there. So we can see, once we create that space, that we have the cables running here through that hole and on to the next side. So you can see it coming here, across through that gap, here, then back and forth. Here we can see the white dot on the cable. That's represented by the red dots on this plan. So that way you know if you're using too much or not enough. Your white mark should end up here on one roll and here on the other. So once we do that, we can then start, we lay out the cables. As you can see, that's actually me doing that. So I'm laying out the cable there in between those sleepers, spaced at 3-inch spacing. And as we do that, then we are going to see kind of like a finished product here of where these cables are. Once these cables are in place, we are then going to use masking tape to hold this cable down. Remember, it seems like 2 hours ago when I was blabbering on about the self-leveling, cables want to float to the top of self-leveling. You have to keep them down. And that's why every 2 to 3 feet, we tape them down with masking tape. The masking tape only has to work for about 2 minutes. It just has to hold it down while the self-leveling is wet. You don't have to worry about, do I have to use high temperature? No. Do I have to use stuff that's really, really sticky? No. You just have to be able to hold it down. And once you do that, you can then pour the self-leveling over the top. This was the first layer. You can see the self-leveling is resting in between the sleepers. What they did is that's not quite enough height. You can't leave a space between the self-leveling and the bottom of the wood going across it, because that's an air gap, and air is an insulator. So you don't want that. You want that piece of wood to rest directly on that self-leveling. And we can see in this picture that it wasn't quite that. So what they did is they just came in and did a very thin skim coat of self-leveling on top of that to get it all completely flat. And that's what the floor is going to look like when it's done. Notice how there's another room over there. The wood is running in the same direction as that wood in the room next to it. So there you go. That's how a nail down installation is done.
Awesome. And then I know we have one more product installation where we did it with a floating floor, correct? We used
Yes.
Environ mats.
Yep. So this is, once again, this is the quickest and the easiest installation. A very, very quick install of this type of floor. You just lay the product out right next to each other. And you can tape, normally I just tape the corners in place because we're just going to hold it in place long enough for us to put the planks over the top, the laminate planks over the top. We're not using this with LVT, but this has been installed over the top of thermal sheet because that's our pad, our 1/4 inch. Now the 1/4 inch is not only because the R value, but it's also a 1/4 inch is the thickness of the non-heating lead. So if you take a look at this picture right here, can you see that, Lynn, where I'm highlighting
Yep.
this? That's the non-heating lead that runs over across the floor up to the thermostat. That's a 1/4 of an inch thick. So unless you want your laminate to teeter-totter over that, what you do is you put a 1/4 inch underlayment so it sits flat. And that's what keeps the teeter-totter from happening. So it gives you your R value, it gives you the padding you need, and it also gives you the thickness that you want to allow those non-heating leads to get back to the wall. A lot of people want to get the cheapest underlayment they can and get that really, really thin 1 millimeter thick blue foamy type stuff. You're going to, it's not going to perform very well. And you're going to have a big, big problem getting those non-heating leads over to the wall because it's so thin. So do yourself a favor, get some good R value, get your quarter of an inch with that thermal sheet, and that's going to cover all the bases for you to give you a good floor. And then once you lay it out like that, you run the cable up to the back of the thermostat, you do the installation there, and there is your final flooring. Very, very quick, very, very easy to install, simply done with Environ flex rolls and a thermostat. So a great, great system
Wonderful.
there.
Wonderful. So this is a little bit more about the temperature that we had discussed earlier. Generally speaking, again, it's usually going to max out at about 85 degrees Fahrenheit, but it will be determined specifically by the manufacturer. So Scott, can you kind of tell us about our thermostats and how they work when it comes to wood flooring?
Yeah, since the sensor is right in the floor, it's going to tell you what the temperature of that flooring is going to be. So the temperature control, once again, maximum 80, ideally 75. That's up to your taste. You can run it all the time at a certain temperature. Now, what you need to talk about to your manufacturer about is about setbacks. And setbacks are traditionally, if you've had floor heating with tile, what you do is you operate the tile at 84 degrees when people are going to be walking on it. Then overnight, when no one's using it, you set it down to 68 or something like that. Then you warm it up in the morning while you're running around getting ready for work. Then when you go to work, the temperature goes back down to 68 or whatever you want it to do. Those are called setback temperatures. And you can only do that. You can either manually do it every morning by hitting up, 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 and then down, 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 like in the old days, or turning that old knob. I'm going to warm it up while I'm home, and I'm going to turn it down while I'm gone. A programmable thermostat will let you do that. But the thing is, many wood and many of these types of product, engineered laminate, they say setbacks are not allowed. A setback, they're not going to let you go from 84 down to 68. Some of them may say you only get 1 or 2 degrees variation per day to operate at. Well, first of all, that'd be very difficult with a hot water system because of all the undershooting and overshooting going on. But with electric, we can keep it right there. So that's what you want to look for. So if you don't need, if you can't do setbacks, then what you're going to have to do is you're going to have to save yourself money and buy yourself a non-programmable thermostat, because it's a set it and forget it. And we're going to talk about that in just a little bit. But make sure you install that floor sensor. Make sure you ask about setbacks. Make sure that you set the maximum temperature. You can go into your thermostat and say, I don't want the temperature to get above this temperature ever. And it will never let the temperature go above that. And because it's floor heating, it has to be GFCI protected. And the GFCI protection is in the thermostat. So check on that stuff. And if no setbacks are allowed, you can buy a cheap thermostat.
Absolutely. And when you are setting up your thermostat for the first time, it's there. We do something called system commissioning, meaning when we're actually starting up at the beginning of a season or at the first time that a product has been installed. So, Scott, can you kind of tell us what that looks like specifically with hardwood floors?
Well, for the people that are watching today, we're in the middle of September, but if you're watching this in 2028 or something, in the middle of the winter, you're going to go, I wonder when they did this. But anyway, we're in the fall right now. And what we're going to be doing is we're going to be going into the cold season here. Once you get to October, those nights start getting cooler. And what you don't want to do with a floor that doesn't allow you to have any setbacks is you're not going to go, okay, it's October 15th. I'm going to go from 65 degrees floor temperature. I'm going to set it to 84 and leave it there. You just can't do that. Okay. Some manufacturers will tell you you have a setback, or you have a plus or minus of 2 degrees or 3 degrees per day, which means you're not going to be setting it on the coldest day of the year. You're going to work about a week and ahead of that point, and you're going to go, okay, I'm going to need to raise this 20 degrees. So I need at least 10 days or more to do that. The first day, I'm going to set it from 65 to 67, or 66 to 68. Next day, 68 to 70. The next day, 70 to 72. And you're going to work your way up to get to the temperature that you want it to stay at. Leave it at that temperature the entire winter. Then at the end, when you are ready to decommission the system, you're going to go from 80 to 78. Next day, 78 to 76, and so on and so on and so on until you turn it off. So those are the things you need to think about. You're not going to go, hey, it's going to be cold, up, 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 up. You're not going to do that because your wood's going to go, whoa, what's going on, right? So that's what we talk about seasonal adjustments and commissioning, decommissioning.
Definitely. And Gary sent in a quick question about engineered wood floors. He says, since they're more stable than solid wood, can you install a maple engineered wood? Absolutely. Again, just making sure you're talking to that flooring manufacturer about, putting radiant heating beneath their product and any specifications they have. All right. So again, looking at some of the next steps, one of the main things that we want to make sure that you are taking away from this is that you want to make sure that you are choosing your flooring material very carefully and that you're talking to the manufacturer. Again, you don't want to just assume, oh, this type of wood is always fine with radiant heating. It doesn't really work like that. There's lots of considerations when you're picking out your flooring. So definitely talk to the manufacturer and reach out to us if there's questions. We'd be happy to take a look at products you're considering to help make sure that our products are compatible with whatever flooring you're looking at. Also, we went over a lot of really great installation tips, making sure that you are matching your heating system to the installation method is key. So again, if you have questions on that, you can always reach out to us, making sure that you're using TempZone products if you're going to be embedding the heating, and using Environ if you're going to be floating it between the floor. Making sure that you're also following all moisture level requirements, all acclimation requirements, and that you're also installing that backup floor sensor as well, are all ways to make sure that that installation goes smoothly and that the floor heating lasts for a very long time to come. And last but not least, making sure that the floor heating lasts is really where system management comes in. And that's what Scott really just talked about recently, or just a slide ago, regarding temperature limits, temperature setbacks, all of that really good stuff. You want to make sure that you are keeping an eye on it and that you're following the manufacturer recommendations. And Scott, I know that you had mentioned a little bit about humidity and relative humidity. Can you touch on that here, kind of what that should look like in the home?
Yeah, I have a friend who has laminate floors, and in the wintertime, his laminate floors gap. They come apart. And in the summer, they go together. Well, he doesn't have radiant heat under those. Radiant heat has nothing to do in that equation. His gapping and his tenting, or whatever you want to call it, is simply a factor of the humidity in that space. So whether you add floor heat to it or not is another thing altogether, but your floor will gap in the wintertime if you don't have the right humidity, whether it's floor heating or not. So that's why it's so important to know about the relative humidity. And I do know back in the day that some flooring manufacturers would install a relative humidity alarm type of device in the floor. And what that would do is once the relative humidity either got below 30 or above 50 or whatever that number they chose, it would indicate to the company, like it would turn red. It would be like a dye thing that would happen, but at too high of humidity or too low humidity, it would indicate that. And then what would happen is the flooring manufacturer would come and they lift up that piece of wood and go, well, I'm sorry that your floor is gapping or it's buckled up, but because you can see right here, the alarm shows that you were below 20% relative humidity. So, I mean, they're on to that. And there is one thing, and I'm going to promise to shut up, but there's one thing that it's very important to think about is if you're thinking about installing a 3-season or a 4-season room, or you're converting a porch or something, you're enclosing it and you're making a room and you want to do floor heat in that space. Well, if you've learned anything from today, you know that these products that you're using have temperature limits. You can't go above a limit. It may be 80 degrees, it may be 82 degrees or 84, whatever that number is. Now, if you were trying to heat these areas that are notoriously difficult to heat, like a three-season room usually doesn't have a very good insulation, may not. It usually has a bunch of exterior walls, usually two or three exterior walls, and it usually has a bunch of windows in it. All those things are heat loss items. They let the heat out of the room. Well, if you are going to heat that floor in that space, you can choose either from one of these systems, which has limited output, 82, 80, 85, whatever those degrees are, or you can choose tile. And tile usually has no limit. You can set it to 102. You could set it to 104, whatever you have to do in that space. Now, if you are taking that space and you want to heat it, would you rather heat it with a system that can only go to 80 degrees? Or would you rather heat it with the system that can go up to 100 degrees of floor temperature? I'm not saying the room's going to get that warm, but you are using a limited uh, uh, system. Uh, so what is your choice? What would you say to people that are looking to heat this space knowing that, Lynn?
Yeah, I mean, it really comes down to personal preference in terms of what you're looking for. If you're looking to make that space very comfortable and use this as a primary heating source, tile is going to really be the best option there, because you can crank that heat up as high as you need to. If you're really just looking for taking the chill out of the floor, maybe you're not looking to really warm up the room, you just want a little bit of a cozier floor, cozier feeling, then wood floors are a great option. You just want to make sure that you're aware of the limitations there.
Right, exactly.
So we did get a few questions. I know some people sent them in early. We also got a lot of questions today. So thank you so much for joining us and asking live. One of our first questions was, can this be installed under a solid opposed to an engineered wood floor? As we said, yes, absolutely. Again, as long as the manufacturer allows it and that you're following the recommendations from them and from us for a solid wood floor. Pablo wanted to know about different installation instructions and the pros and cons, which we went over, discussing the different applications that we have and where each one comes into play. But if you have specific questions on your project, definitely reach out and we can always help find the best system. Pam wanted to know about specific brands of floor coverings. So obviously there are lots of different brands out there. Each one has different recommendations and requirements when working with electric radiant heat.
And
So
and they change all the time.
and they do change all the time. Yes. So we don't have exactly a list or a database of all of the brands that can go over our radiant heating systems. And that's really because it's important to be talking to the manufacturer.
And they'll be able
And
to tell you if you say, I like this type, ask the manufacturer, is it compatible with radiant heat? Yes or no? Yes. Okay, fine. What's the relative humidity requirements? Okay, done. And that's all you need to do. But it's such a moving target. What brands allow this? Well, this brand used to allow all of it. Then they said, no, we don't allow any of it. And as I said, it changes all the time. So you never know. So it's always just, if you like something, ask the manufacturer and see if it's okay. A lot of times they'll say, sure.
definitely. Yeah, it's becoming very common for them to allow radiant heating under their products. So they'll usually have an answer right off the bat for you. And then warranty, we do have an industry leading warranty on all of our products. Our TempZone product, floor heating is 25-year warranty. Our Environ product is a 10-year warranty. So it will vary depending on the specific product that you're using, but all of that comes with our 24/7 tech support and obviously just being able to reach out to us whenever if you need any assistance.
Yeah,
And then
the one thing about our environment is our environment can also be used for stretching carpet in the United States, which
yeah,
actually goes between the pad and the carpet. It has a 5-year warranty for that. So simply because it's a higher wear, it's the carpet's always pushing down on it. So that's the one small difference in Environ between one to the other.
absolutely. And Scott, can you kind of talk to or speak on the durability of the click and lock type laminate? I know we kind of mentioned it earlier, but just kind of talking about that for Lisa.
Yeah, that's a great question, Lisa. And we haven't really had with Environ and laminate, we have very little issue with that. It's stools and ladder feet. Those usually don't exhibit, a tons and tons of PSI that's going to deform and break your product if it was installed correctly. Now, if it's gapped and then you put a real high point load right there, there's a chance that you can do that. But my recommendation is you usually don't have to worry about stools and ladders, that sort of stuff. Now, if you're talking about installing grand pianos, or if you're going to be installing things that are very, very heavy, like bookcases and stuff like that. First of all, you'd never install a bookcase over any type of floor heating. You can't do that. But the thing is, if you have something that's got a really high PSI and it's concentrated really huge on this one area, on this little tiny bit of foot that sits down, that may be a situation where you want to take not use the Environ, but use the TempZone product and cover it with a 1/2 inch of self-leveling, and then lay your laminate on top of that, or lay your LVT on top of that, or lay your engineered wood on top of that. And now you have a very, very solid underpinning. You don't have to worry about those point loads breaking that joint. So if you're talking about, really, really heavy items, I suggest using the TempZone covered with self-leveling, and that's going to give you a very firm subfloor to work with. But for stools and ladders and that sort of stuff, you shouldn't have to worry about it. But great question.
Absolutely. So our next webinar will be next month on October 9th, right here on Zoom, again at 1 o'clock Central Time. And then we will be talking about product selection and sizing. So we're going to go over picking out the best product for your specific application and making sure that your radiant floor heating project is a success all the way through. We do also have Radiant training sessions every Tuesday, Wednesday, and Thursday at 1 o'clock Central here on Zoom as well, often hosted by me, hosted by Scott. So feel free to pop in for those. They're generally a little bit shorter, about a little bit more of a niche topic. And then always, of course, if you have questions, you can pop in and ask those right away.
But the good thing about watching today is you get a 10% off coupon that you'll be getting information about. So remember that.
Absolutely. And again, if you ever have questions or need anything at all, we would be more than happy to help out. As you can see, we have our phone up here, we have our email available. Our website is a treasure trove of information. Anything you could ever want to know about radiant heating is on that website. So definitely reach out to us if you need any assistance at any point, and we would be more than happy to help.
And
All
that's
right.
it.
And I
That's
think
the
that is
last
all we have.
slide. That's the last slide. Let's
Yay, we did it.
let's put that there instead of my face. One of my faces is enough.
Fair enough, fair enough. And if there are any other questions, again, always feel free to reach out. We would love to see you at one of our other live training sessions. But that is all we have today. So thank you so much for joining us. Check out your email for that 10% coupon for joining us live today. And as always, stay warm and be
Be
radiant.
radiant. See you later.